Hey guys, so today we're going to do your favorite lessons, and that is these real life application problems, so what you guys know as word problems. So I will introduce you to about 1, 2, 3, 4, 5-ish formulas. So we're just going to kind of do them slowly by sections. If the video gets too long for you, then just pause it, take a breather, and then come back. If you think you got it and you want to fast forward to the next section, you are more than welcome to. But we're going to start with the basic exponential growth and decay formulas. Basically, if it's growing, it's going to be a plus sign. If it's decaying, it's going to be a minus sign. So you're going to have f of t. Okay, and later on, we're actually just going to change and use an A, a capital A, and this basically just means your ending amount. Like, basically, what are you going to have at the very end when it's all said and done, okay? Then we have small a, which is your initial amount, and then we have 1 plus your rate, and rate needs to be as a decimal, okay? And then to the t power, that's how length of time that it's going to be, okay? Initial amount for that A is also, if you want to think about what you're starting with, okay? And all those definitions are the same for the decay one. Just know that it's a minus sign instead, okay? So example 1, Kylie started her career with an annual salary of $32,000. Each year thereafter, her salary increased by 2.5%. So that looks like it's in a decimal, but it's in a percent. So we need to change that to 0.025. Now, some of these problems will ask you to write and use one. So this one is asking you to write the equation and then actually use it to figure out her salary when she retires after 30 years. So that means we are trying to find the ending amount after 30 years. So to write an equation, we just plug everything in except for that time. So that means we are going to have 32,000. 1 plus 0.025, and then to the t power. That would be like we're being able to write it just the equation, because then you can plug in 30 years, 28 years, 10 years, whatever you would like. So now let's actually go plug in 30. And then all you have to do is type this into your calculator and get your final answer. So you should have $67,122.16. Okay. The next one says Kate drank an energy beverage with 150 milligrams of caffeine. Each hour, the amount of caffeine in her system decreases by 12%. So let's change that to a decimal. Write and use an exponential decay. So we know it's going to be the minus sign in the parentheses based off them telling us it's a decay, but it also says decreases. To find the amount of caffeine in her system after 8 hours. So again, we're finding that ending amount. So we're going to have f of t. She started with 150 milligrams of caffeine in that beverage. 1 minus 0.12 to the t power. So now we want to actually plug in our time of 8 for 8 hours. So we can type this in to the calculator, and we would get approximately 53.95 milligrams. Okay. So let's go to the next one. Mark started a new blog to write about his travels. In its initial week, so that would be its initial amount, he had 800 readers. From this point on, the number of readers each week increased by 25%, so 0.25. Use an exponential growth model to find the week. So this time we're asked to find time in which the number of visitors reaches 10,000 people. So this would be like that function of time slash capital A like I mentioned, okay? So let's go plug everything in. So this time we have 10,000 equals 800, 1 plus, because it's growth, 0.25 to the t power. So basically now you just got to be able to use your solving skills. So we got t on the right hand side. So the first thing we need to do is get rid of that 800. And it's attached by multiplication, so let's divide by it. Okay, so we should get 12.5 equals 1.25 to the t power. And then let's natural log both sides. So I'll just put a little natural log. And then we have natural log of 12.5 equals t natural log of 1.25. So then we want to divide by that natural log of 1.25. So t is equal to whatever this is. So when we type that into our calculator, you will have what t is. So t is 11.3. So we're looking at about 12 weeks. Okay. Now the next question is slightly different. This is a half-life question, but you kind of still use the same formula for it. So a certain medicine has a half-life of 5 hours. If a patient is given 500 milligrams at noon, at what time will they have 100 milligrams remaining in their bloodstream? So they're starting with this. So this is our little a. They're ending with this. So this is like our function of time slash capital A. Okay. So let's see what that looks like. So we're going to have 100 equals 500. Now, this is a half-life. So if you think about it, that's like 50%. So we are going to subtract 50% from 1, okay, because it's half-life. And the medicine's going down. You're starting with 500, and then you're going to 100. Now, the time, though, okay, isn't just going to be a time, because its half-life happens in about 5 hours. So we are going to have to divide the time by 5, okay? Because that's the rate at which it decreases. So let's go ahead and divide by our 500 like we did in the last problem. So we have 0.2 equals 0.5 to the t over 5 power. We can natural log both sides just like we did. So we have natural log of 0.2 equals natural log of let's go ahead and bring down the power. So we have t over 5 natural log of 0.5. So we want to divide by the natural log of 0.5 equals t over 5. And then basically, how do we get rid of that 5? So if we're dividing by 5, the opposite would be to multiply by 5. So that is what you would need to type in the calculator to tell me what t would be. And t would be approximately 11.6 hours. Okay, so it's actually asked us for what time. So if we're sitting at noon, we got 11 hours, and then 0.6 of 60 minutes would be 36. So we're looking at 11:36 p.m. Okay, hopefully those problems were okay for you. We're going to go to the next type. So this one is continuous growth and decay. This will be the actual same formula that we use in just a second. I like continuous because if you can think of continuous as PERT, you will never forget it, and this is why. Okay, this is where that capital A comes into play that I told you about. The only difference is instead of a lowercase a, we have a capital P. This is your starting amount, your initial amount. And then we have our E to the R T power. R will be positive if it's a growth model and negative for a decay model. So on example 5, a garbage dumpster started with 4 pounds of garbage. The amount of garbage increased continuously by 35%, so 0.35 each day from this point forward. Find the amount of garbage in the dumpster can after 2 weeks. So I'm finding it after 2 weeks, so that's the final amount. Remember, that is your capital A. Okay, so we're just going to go A equals 4E to the 0.35 times. This is 2 weeks. Okay, everything was based off of a day. So 2 weeks equals how many days? So that would be 14 days. So that should actually be a 14 right there. Okay, so you should be able just to type that one straight into your calculator, and we get approximately 537.16 pounds. Okay. Example 6, the population of a town is declining. So this is going to be a decay at a continuous rate of 1.5%. So remember, move the decimal twice, so 0.015. If the current population is 16,000, what's the population in 8 years? So again, we're wanting to find that capital A. So we're starting with 16,000. E to the negative 0.015 times, and that is okay per year, so we can multiply that times 8. So we are looking at, when you go to type this into your calculator, about 14,190 people. Okay, example 7, a new stock entered the stock market in January 2012 at 72 cents per share. 4 years later, the price of each share was $3.85. Using a continuous exponential growth model, find the growth rate. So that means we are looking for R. So it started with 0.72 and it ended with 3.85. We have E. We don't know the rate, but it was 4 years later, so multiply times 4. So we would want to divide by 0.72 on both sides. So we get 5.3472 equals E to the 4R power. Natural log both sides. Good thing is these natural logs cancel. So we get natural log of 5.3472 equals 4R. And then all we have to do is divide by 4. So we get roughly 0.4191 when you go to write that. So this would give us approximately 41.9%. Okay. So the next one is the logistic growth function. And honestly about this one is they're going to give you a model, and based off that model, you just got to plug everything in. So example 8 says a disease begins to spread the town of 20,000 people. After T days, the number of people who have been infected by the disease is modeled by the function below. Using the function, find the number of people infected after 10 days. So basically all you have to do is plug in the 10, type it into the calculator, and you have your answer on this one. So we're going to have our 20,000 over 1 plus 1150 E negative 0.95, and then our time is 10, so we just have to plug that in. So you just need to very carefully type this into your calculator, and you should get approximately 18,415 people. Okay, try not to take my word for it. Please practice typing it into your calculator so that you know when you go and do these problems that you would be getting it right. So example 9 says the population P in millions of a country from 1850 to 2000 is modeled by the equation below, where T is years since 1950. Using the function, find the population of the country in 1920. So what is the years difference between 1850 and 1920? Hopefully you said 70. Okay. So type that very carefully into your calculator. Please remember P is in millions. So when you get your answer, you should have 12.19 millions. Okay, a small lake is stocked with a certain species of fish. The fish population is modeled by the equation below, where P is the number of fish in thousands. Okay, so we have another thing, kind of like the one above. And T is the number of fish. T is the number of years since the lake was stocked. How many years will it take for the fish population to reach 6,000? Okay, so this time we're not looking for P, that we're wanting to know when it would reach 6,000. So that's where we have to be very careful, and this statement comes into play here because P is in thousand. So the only thing you can plug in is 6, which is kind of a good thing because it makes it easier on us. We don't have so many zeros. Okay, now here's where T is in the bottom. And I know a lot of you guys would say just multiply both sides by the 1 plus 3. And that is completely right. So I'll kind of show it right here. Like this, because I don't want you multiplying it out. Because in all honesty, what I need you to turn around and do now is divide by that 6. It makes our life so much easier. So I don't know if you remember when you were first learning how to solve for equations, but sometimes you could just switch these. Okay, so we're going to have 1 plus 3e to the negative 0.7t equals, and that reduces down to 4/3. Okay, but remember that E is not by itself, so we have to keep solving it until that E is by itself. So we need to subtract 1 from both sides. So 3e to the negative 0.7t equals, now it's a 1/3. Divide by that 3 or multiply by the reciprocal, whichever way you want to look at it. I'm going to do it as 1/3 so I don't have to pick up a calculator and try to figure anything out. So this would change to 1/9. Now you can natural log both sides. Those cancel. So 0.7t equals natural log of 1/9. And then, of course, to finish out the problem, we just need to divide by the 0.7. And I left off my negative. So hopefully somebody caught that. Someone put my negative back in there. There we go. She definitely can't have time coming out to be negative. So we got T is going to equal about 3.14. So we have approximately about 4 days for that to happen. Okay. The next one is compound interest. Okay. So everything is kind of the same except for we have a new letter, which is N now. So the formula is A, which is still your total balance, final amount. Okay, which way you want to look at it. P, that is your initial amount. Okay, because it's your principal. 1 plus R, that's your rate. Remember, it needs to be a decimal. Divided by N, that's our new one, to the N times T power. T is our time, okay? N is your number of times compounded, and this is yearly. Okay. So when Amelia turned 6, her grandparents opened a college savings account for her with an initial deposit of $500. So that would be our P. The account earns 3.2 interest. So that would be 0.032. So I'm going to have 1 plus 0.032. Compounded by monthly. So this is where you have to think about it. What if I'm compounding something by monthly, how many times would that be a month? Well, hopefully you said twice a month. Well, if it's twice a month, how many times is that per year? So hopefully you said 24. So I put a 24 there and a 24 there. If her grandparents make no other deposits or withdrawals, so the only money that was put in there was the $500, how much money will there be in the account when she can get it at age 18? So if they did it when she was 6, we want to know how much at 18, how many years is that? And hopefully you said 12. So that means we are looking for A. So this is where you will have to very carefully type this into your calculator to figure it out. So that would be $733.88 because they didn't add any extra money into it or take anything out. Okay. So let's look at 12. 12 says if 500 is deposited into a retirement account, so again, we're depositing 500, pays an annual interest rate of 4%, so it's 0.04, so 1 plus 0.04, and it's compounded quarterly, okay? So quarterly means how many times? Well, quarterly means 4, so therefore, how many times would that be in a year? Well, 4, so that'd be like every 3 months. So we're going to put divide by 4 and 4. How long? So that means we're looking for T. Will it take the account to reach a balance of 1,200? Okay. So just like the other ones, we need to divide by that 500 first. And that comes out to 2.4. Then what I would do next is I would type the inside right here in the calculator. Okay, so 0.04 divided by 4 and then add 1 to that. And you should get 1.01 approximately. And then we just finish the problem like normal. Natural log both sides. Drop the 4t. I would just go ahead and divide by 4 natural log of 1.01 because that makes that cancel and t's by itself. Okay, so we should type this into the calculator and we get approximately 22 years. Okay. Okay, so we are about done. This is our last little section to do. And the good thing is it's going back to the continuous one that we just did a second ago. And guess what? It does not change. So it is still your PERT. Okay, so remember, you only use the continuous one when it says continuous. If it says compounded, you use the compounded formula. So suppose $800 is invested in an account of 6%, so 0.06, and it's compounded continuously. That's what tells you that you're using PERT. So $800 is invested, and we have 0.06. If no other withdrawals or deposits are made, what would the balance be after 20 years? So the good thing is we are just putting a 20 right there, and we're trying to find the balance at the very end. So you just want to type that into the calculator, and we would get $2,656.09. Okay. Okay, this next one is where you get to decide which one is actually a better option for investing money. So Carla is investing $1,500 in a new 30-year retirement account. Determine which of the interest rates and compounding periods shown to the left, or I guess below for us, would be her best option. So here's option A. So notice this one says compounded monthly. So because this one says compounded monthly, we are using this formula. Okay. The next one says compounded continuously. So that is our PERT. So if you would like to just pause the video right now, you can, and then work this out and then see if it matches my answer. Okay. So let's go plug everything in. We know that the initial amount is going to be that $1,500. The rate is 0.055. It's compounded monthly, so that means every single month. So there's 12 months in a year. And it's happening for 30 years. So all you have to do is type that into your calculator, and we get $7,781.08 for option A. So we come over here to the continuous one. It's still $1,500. But this time our interest rate is 2.7, so it's 0.027. And again for 30 years. So you type that into your calculator, and that would be $3,371.86. So based off of this, since you are investing money, you want more money, okay? So that means option A is the one we need to go with because it yields more money. Okay. Okay, example 15. Okay, Dave deposits $500 into his savings account. After 15 years, the account balance has tripled. Okay, so that's a final amount. It tripled. And if he deposited $500 and it tripled, how much does he have now? Well, hopefully you said $1,500. Okay, using compound continuously. That is PERT. But this time, we're looking for the rate. So we know that it's going to equal 1,500. Started with 500. The rate is, oh, that's what we're looking for. Sorry. And this was after 15 years. So the cool thing is we know if we divide that by 500, we should get a 3. And then we just finish the problem like normal. So we are going to natural log both sides. So we have natural log of 3. These cancel, so 15R. And then divide by 15. So type this in the calculator. You get R equals 0.0732. So 7.32% would be our rate on this scenario. Okay. And example 16 is kind of like the same, on the same lines. As you can see, it's compounded continuously. Scarlett invested $8,000. You want the account to reach $10,000. The rate is 7.5%, so 0.075 as a decimal. And then how long would it take to reach it? So we pretty much just solve it the same exact way. So divide by the 8,000. Okay, so we get 1.25 equals e to the 0.075t. Again, we just solve it like normal, natural log both sides. So we get natural log of 1.25 equals 0.075t. And of course, we want to divide by that. Okay. So you just want to type that into the calculator. You get like 2.975. So this would be approximately 3 years. Okay, so that is all the examples for you. The only other thing that I would like to touch on before I let you loose is making sure that you understand what this N is. And what I mean by that is it's yearly. So anytime it says compounded, like semi-annually, well, annually means one time a year. So if it's semi-annually, then that would mean N is 2. If it was weekly, compounded weekly, well, how many weeks are in a year? 52. So N would be 52. If it was compounded daily, well, how many days are in a year? Well, that's 365. So just kind of ask yourself, that is all based off of years. Okay? So I know it was a lot. Do the best that you can, and we will talk about this tomorrow.